Alright guys, so solving some polynomial equations using factoring here. Again, just keep in mind a lot of equations will not be factorable, but if they are, it's sometimes easier than having to go through a longer process. And sometimes they're even already factored. If you take a look at this example 1 here, that's already in factored form. So since it's equal to 0, it's in factored form. This is kind of like a good example for us because we don't have to do that much work. We know if we have some things being multiplied, and they equal 0, that means that one of the factors must be 0. So either x minus 4 is 0, which means x equals 4 is one potential solution, or is one of the solutions. Or the other factor, x minus 1 equals 0, so x equals 1. And the third factor, x plus 1, if we set that equal to 0, we would get x equals negative 1. Okay, so we're getting 3 answers here. All of them need to be listed. All of them are solutions to the equation. It's just using that zero product property. Now, if this wasn't a 0 over here, we couldn't do that. So in some problems, you got to get it set equal to 0. If you remember when we did quadratics and the quadratic formula even, it involved getting it set equal to 0, and then you can kind of do some things on there. All right, let's take a look at example 2. We have x plus 4 times x squared minus 4x plus 16 equals 0, and we are solving for x. Okay, so again, it's sometimes tempting. You see something like this to distribute everything out, multiply it all out. We don't want to do that here. Okay, we're solving for x, so having it factored is better for us. So we're just going to set the factors equal to 0. Okay, so the first one, since it's just a linear factor, those are the easier ones to solve. So x equals negative 4. Here's one solution right there. And the other factor happens to be a quadratic, right? It's x squared minus 4x plus 16. So to solve a quadratic, that's when we would either factor it further if possible, or maybe just jump right to the quadratic formula. Okay, so let's take a quick peek. Any factors of 16 that add up to the negative 4 in the middle? I don't think so. So let's go right to our quadratic formula to solve it. So opposite of b, so positive 4. Plus and minus the square root of b squared minus 4 times our a value, which is 1, times our c value, which is 16. And that entire expression is all over 2 times the a value, so 2 times 1. And let's see if we can simplify this down some. So 4 plus and minus, we have negative 4 squared is 16. Minus 4 times 1 times 16 should be 64. All over 2. Okay, so then we have 4 plus and minus the square root of negative 48 all over 2. Okay, and we do want to reduce these as much as we can. That square root of negative 48, okay, first off, since it's negative, we're going to bring out the negative 1, okay, and then times 48. Now with 48, we want to get it broken down into factors, but we want to choose the correct factor where one of them is a perfect square. So since 48 is equal to 16 times 3, let's go that route as opposed to some other way to get 48, because 16, again, is a perfect square. So the square root of 16 is 4. Right? The square root of negative 1 we're calling I. And then the square root of 3 here, we can't really break that down at all. So the square root of the negative 48 really just becomes the 4i square root of 3. And this whole thing is still all over 2. And then what we can do if we want to simplify even a little further, if you take a look, each of the coefficients here, they're both divisible by that 2 down there. So let's just kind of reduce them down all the way. The 4 divided by 2 becomes 2. The next 4 becomes 2. We do not reduce what's under the square root. Because it's under a square root. It's not just like a whole number. Okay, so we can, again, what happened here, that became a 2, that became a 2, and this became a 1 down there. So I didn't write the 1 in the denominator. Okay, so our final solutions to this equation, don't forget about, we had the x equals negative 4 from the beginning, and then we have the 2 plus and minus 2i root 3. All right, so let's do a couple other examples. So those first two, again, everything was already factored. Okay, so those were, again, kind of best case scenario. Sometimes, a lot of times, they're not going to be factored, so you're going to have to do some work here. All right, so let's take a look. So we have x cubed plus 27 equals 0. Okay, this one, is that factorable? Okay, from the last section, this is actually the sum of perfect cubes. Okay, so a lot of times if something just has two terms like that, you can try and see, are they both something to the third power? And in this case they are, right? Because x cubed is just x cubed, and then 27 is just, could be written as 3 cubed. So our formula for that, for a cubed plus b cubed, from the previous section, okay, remember, was a plus b times a squared minus ab plus b squared. Okay, so that's either a formula you should have in front of you or have memorized after we do this a few times. And what that's going to do, it's going to allow us to factor our expression, okay, because what we're going to do is the x is basically going to be like where the a's are, okay, and the 3 is going to be our b terms, okay, and then this one in the middle will be the product of them both. So let's walk through the factoring of this. Okay, it's going to be a plus b, so x plus 3. Okay, and then we're going to do the a squared minus ab plus b squared. So it's going to be x squared minus the a times the b, so the x times the 3, and then plus the b term, which is 3 squared. Okay, so that was the step to get the thing, to get the expression, factorable, or factored, I should say. And now we still need to solve the equation. But now that it's factored, we're just going to use the zero product property. Set each factor equal to 0. So x equals -3 is one solution. And then we do have ourselves another quadratic here. Okay, so let's see what we can do. Quadratic formula again. So opposite of b is going to be 3 plus and minus the square root of b squared minus 4 times a times c, right, all over 2a. Okay, so I got everything plugged into the quadratic formula, so that's not going anywhere. Make sure we still have that. 3 plus and minus the square root of, we have 9 minus 4 times 1 times 9 is 36, all over 2. Okay, so then we're going to end up with simplifying 3 plus and minus of 36 minus 9 is 27, so -27 over 2. And then let's see, what can we do with that square root of -27? To simplify that, I know again the -1 needs to come out. The 27 we can do as 9 times 3. Okay, and that's going to help us because 9's a perfect square, right? So the square root of 9 is 3. The square root of -1 is I. And then the square root of 3 is just the square root of 3. So what we have is 3 plus and minus. We simplified that to be 3i root 3. And it's all over 2. Okay, and we cannot reduce any farther because the coefficients in the numerator are not divisible by the 2. Okay, so our final answers again are just the x equals -3. And then this is actually 2 answers, right? Because we have the plus and the minus. So we had a total of 3 solutions, okay? And that's going to end up being the case. We're going to see that whatever the degree of the function is, in this case it was originally a 3rd degree, that's how many total zeros you're always going to have. That's actually the fundamental theorem of algebra. All right, so let's take a look at another example. Let's see if we can get this guy solved here. X, another 3rd degree, x cubed minus 5x squared plus 4x minus 20 equals 0. Okay, so we got to think about our factoring methods first. Okay, this one, it's definitely not the sum or difference of perfect cubes like the last one. It's not a quadratic. So with the 4 terms, what comes to mind, what to try, and we checked to see, or I checked, hopefully you did too, to see if there was any common factors across the board, all 4 terms. And since there's not, that's when you're going to want to try this grouping method. Okay, so again, this thing has 4 terms. I'm going to see if I group it into 2 groups of 2. Let's see if it can be factored. So in the first 2 terms, the common factor is x squared. And then if we factored out an x squared, we would have x minus 5 left over. Okay, in the other terms, the 4x minus 20, 4 goes into both of those, and we would be left with x minus 5 as the leftover factors again. Okay, so now we have everything factored. we did end up with that common factor. Each of the terms has an x minus 5 there, right? So that's going to be something that we can bring out front as a common factor. And the leftover stuff will be the x squared and the plus 4. Okay, so we got this guy factored. Okay, so that's nice. Let's set the factors equal to 0. See what we get. So x minus 5 equals 0. X equals 5 is the solution to our equation. Okay, now the x squared plus 4 equals 0. We need to solve that for x. It's not factorable over real numbers, but we can get x by itself because there's no middle term in there. It's just x squared plus 4. So we could actually just kind of old school get x isolated. Subtract 4 from both sides. X squared equals negative 4. And then when you go and take the square root, right, because we want x, okay, we do need to do plus and minus like we did in the quadratic chapter. Now the square root of negative 4, remember negative 4 is negative 1 times 4. Okay, so it's just going to become plus or minus. We know the square root of 4 is 2. We know the square root of negative 1 is I. Okay, so we actually get two imaginary solutions on this one to go along with the one real solution of x equals 5. Okay, so there's all three solutions to that equation using grouping first. All right, so let's do one more equation. This one's a different style as well. So we have x to the fourth minus 5x squared plus 4 equals 0. Okay, this is one of those where it doesn't really look factorable, I don't think. There's no common factor. There's no perfect difference of perfect squares or cubes. It's not going to be grouping because there's only 3 terms. So this is that one that we call quadratic form, where if you look at it, it's very similar to this expression or this equation, x squared minus 5x plus 4 equals 0. And the reason that it's in the same kind of same neighborhood of functions or same style, if you take a look at the exponents, the middle term is half the degree of the first term, which is similar to what happens here. This would have been x to the first. So if we think about how we would factor the one on the right, since it's x squared, we know we just need to have x and x in the first terms, and then we would be looking for factors of 4 to fill in here and here that add up to negative 5, so we could do like minus 4 and minus 1. And then we could finish that out. But our problem's very similar, except that it can't start with x and x, but it can start with x squared and x squared. That would get us the x to the fourth here. And then we're doing the exact same process to get the middle terms. Okay, factors of positive 4 that add up to the negative 5. Okay, so it factors just like the quadratic. That's why it's called quadratic form. Clearly not a quadratic function. It's a 4th degree polynomial. Okay, but it is factored, and we could actually do we could do a few things here. We could factor further, or we could just set them equal to 0 right now and finish like we did the last one by taking square roots. But let's factor all the way. Now that I notice in this is actually the difference of perfect squares, and so is this, right? So we could keep going and say, all right, x squared minus 4 is really x plus 2 times x minus 2. X squared minus 1 is x plus 1, x minus 1. Okay, and if you can factor them all the way down to linear factors like that, it's going to make this last step even a little quicker. Now setting each factor equal to 0, we get a solution of x equals negative 2. X equals, setting this one equal to 0, x would equal positive 2. Setting that one equal to 0, we get us x equals negative 1. And x equals positive 1. So we got 4 real answers here. Which is what we should expect again of a 4th degree polynomial. Okay, last thing I want to go through, what if I were to give you, think about this, if I were to give you these answers right here, could you kind of work your way up to come up with the expression that got it? So think about like when you get negative 2, you kind of know x plus 2 was a factor, that kind of thing. So let's take a look at one of those. Can we write a polynomial function of least degree, okay, with integral with whole number coefficients that has the given zeros? Okay, so let's think about that. So these here again are like the answers to the equation, okay, or the answers to the equation equals 0. So if we think about if 5 is one of the zeros, that means that x minus 5 is one of the factors. Okay, because if we set x minus 5 equal to 0, we would get 5. Okay, if negative 3 is one of the zeros, that means that x plus 3 would be a factor. Okay, again, setting x plus 3 equal to 0 would get you x equals negative 3. And the positive 1 as a 0 means that x minus 1 is a factor. Okay, so it's always kind of like going to be the opposite of what they give you. If they give you a positive number, you're going to have x minus that number. If they give you a negative number, you're going to have x plus that number. Okay, so our equation, there's an equation, right? That equation would give us the 3 zeros. As written, though, this is in factored form, and they want it to be written as a polynomial with coefficients. So they want us to multiply it out. So let's go ahead and do that for them. So we're going to multiply it together, and let's just multiply it. Let's like FOIL out these first two, and then we'll come back and get the x minus 1. So multiplying those first two, the x minus 5 times x plus 3 will give me x squared. Doing first outer, inner, last here, right? So plus 3x minus 5x, and then minus 15. And again, we still have to multiply by the x minus 1 at some point. Let's just clean up those middle terms there, and then we'll do the one more distributing here. So x squared, the plus 3x minus 5x can be combined to be minus 2x. And then the minus 15's there, still times x minus 1. And now let's multiply this all out. Okay, so I'm going to distribute the x squared first. So x squared times x is going to be x to the third minus x squared. Then let's distribute the minus 2x to each of those. So minus 2x squared, and then a plus 2x. And then I will distribute the minus 15, minus 15x, and plus 15. And then now, as soon as we clean up the like terms, we will be done. So x cubed, the minus 1x squared minus 2 more is minus 3x squared. The plus 2x minus 15x would be minus 13x. And then we have a plus 15 equals 0. So now we have ourselves a polynomial. Okay, all the coefficients are nice whole numbers. We're not dealing with any fractions that we need to worry about. And it's actually in standard form because the exponents are decreasing. It's third power, then second power, then first, and so on. All right, so that is finding the equation if they give you the zeros.